Hi, in today's video, we're going to talk about inverse function, which is section 1.5 of our chapter 1, page 119 through 128 in our textbook. And the best way to start talking about inverse functions is to give example of inverse function. The best example of inverse functions would be the exponential and log. So let's complete the table for exponential and log and understand the relationship between the exponential and log. So first of all, to start with, we're going to talk about the domain of an exponential function. And the exponential function is the one in red. If you guys can recognize that when talking about inverse functions, the best example again would be exponential and log. So the domain of an exponential function would be negative infinity to infinity. Remember, when we talk about domain, we are reading, if we're reading it from a graph, we are reading left to right and we read the x values. So on the very left, the graph is going to the negative infinity values. On the very right, the graph is going to the positive infinity values. It's going all the way to the right. So let's write this. Negative infinity, comma, infinity is the domain of an exponential function. Now, let's talk about the range. So the range is bottom to top, lowest part of the graph, highest part of the graph, and you read the y values. So the lowest part of the graph does not touch the x-axis, but gets very close from the x-axis. And the x-axis has the equation y equals 0. So the range starts at 0 and goes all the way up, which is to infinity. So when we talk about the domain, we're talking about x values. When we talk about the range, we are talking about y values. For the log function, and here specifically the natural log, which is the blue graph right here, if we talk about domain, so left to right, most to left, which is this part right here. If you guys remember, we call it asymptote, is the y-axis, and the y-axis has the equation x equals 0. So this starts at 0 and goes all the way to the right, which is infinity. And the range is bottom to top, so this blue graph goes all the way down to negative infinity, and it goes all the way up. It keeps going up and up to positive infinity. And I think now we can see a little pattern right here, which if you look at domain and range of log function, you can see how they are switched around. So the domain of exponential is the range of a log, and the range of exponential is the domain of a log. Now let's see how is that going to help us. So for asymptote, for the red graph, we just said it's the x-axis, which has equation y equals 0, so the x-axis. And this definitely would be a horizontal asymptote. And for log, it has the y-axis, which has the equation x equals 0 and is a vertical asymptote. So also we're talking about y equals 0 versus x equals 0. Remarkable points, like important points on the graph. So for the red one, which is the exponential, we can see that this is a remarkable point, and this is a y-intercept. So a y-intercept versus for the log, you're going to see that it's an x-intercept. Okay, so let's continue this video. I'm sorry for the interruption. So as we see right here in the table, the x and y's are switched. So we said the domain switches with the range switches with the domain, horizontal asymptote versus vertical asymptote, y-intercept versus x-intercept. So we can understand that the relationship between inverse functions is basically switching the x and the y. In other words, switching input-output. So in the next slide, we're going to see how our objective is to find the equation of an inverse function, and it's not only going to be exponential and log. You can be given any type of function, and the question would be to find the equation of the inverse. Now, the first thing we want to do, we want to get familiar with the notation. So this notation, we read it inverse of a function. This is not an exponent, so just to stress this, we don't read it f of -1 or f to the power -1. This simply means we're looking for the inverse of the function. So we're going to follow two easy steps. The first step is going to be to switch the x and the y. So I'm going to rewrite f of x as y, and I think we all agree on this. And the first step is going to be to switch the x and the y. So I'm going to do that. X equals 2y plus 1. So what I did is I switched the x and the y. So the x became a y, the y became an x. Now, second step, we want to solve for y. So I want to get y by itself. So I'm going to do everything to solve for y. So I'm going to subtract 1. X minus 1 equals 2y. And to get y by itself, I'm going to divide by 2. So y is going to equal x minus 1 divided by 2. Now, this is going to be the equation of the inverse. But we can't have the same notation, like y equals 2x plus 1 and y equals x minus 1 over 2. We need to rewrite this using the inverse function notation. So that last step is required and important. So the inverse of f of x, which is 2x plus 1, is x minus 1. And a little bit clarification to understand the concept of inverse. If you look at this, the original function, it simply means take a number, which is the input, multiply it by 2, and add a 1. What the inverse does, it's undoing what was done, if that makes sense. So it's going to say subtract the 1 and divide by 2, which is the inverse process of multiplying by 2 and add a 1. So this is the first example. Second example, we need to find the inverse of f of x equals square root of x plus 2. And this, if you guys remember, is a square root function. A square root function. So I'm going to rewrite f of x as y. That's the first step. I'm going to switch x and y. So y becomes an x and x becomes a y. And remember, my aim is to solve for y. And I have a square root. So in order to get y by itself, when you have a square root, your only option is to square both sides, because a square cancels out the square root. So I will have x squared equals y plus 2. Subtract the 2 on each side, and you're going to get y equal x squared minus 2. Remember the notation, the inverse function is x squared minus 2. And as you guys notice, you start with the square root function. The inverse of a square root is a quadratic. And this makes so much sense because think about it. 2 squared is a 4. Square root of 4 is a 2. So when you switch the input-output, this is what you will have. A square root function turns into a quadratic function. Now, the third example, we're just going to do it very quick. It's pretty simple. So this is a cubic function. The inverse of a cubic would be a cube root function. And this would be the graph of a cube root function. Now, the last example might be the most challenging one. As you guys see, this would be a rational function. And the question again is to find the inverse. So we're still going to follow the same steps. I'm going to write, instead of f of x, y, I'm going to switch the x and the y. And a good question here would be, do I switch both of them? Yes. I switch both of them. And then when you get to this step, you can put this over 1 to make it clear that you can cross multiply. 1 times y is y, and x times y plus 1. Just make sure you put parentheses because the x has to be distributed. And I'm going to continue right here. So y equals xy plus x. Remember, I want to solve for y. So I want all y terms to be on one side. So I'm going to subtract xy. So y minus xy equals x. And also keep in mind, you want to solve for y. So this is a very important step. You're going to factor out the y. And a quick reminder about how to factor out a common factor. Factor by a GCF. Like if you have 2x squared minus x, the common term would be x. To get what's inside the parentheses, you're going to divide 2x squared by x. You're going to get 2x left. You're going to divide negative x by x. You're going to get negative 1 left. This is how we factor by GCF. So I'm going to do the same thing here. And you can tell that y is the common factor. I'm going to open parentheses. Y divided by y is 1. Negative xy divided by y is negative x equals x. And also remember, you need to solve for y. So you want to divide by whatever is next to the y. And you're going to get y equals x over 1 minus x. And don't forget to write the inverse notation. So I'm going to write it right here. Inverse of f of x equals x over 1 minus x. And this would be the inverse function. Now it's your turn to practice this. You're going to work on page 126, 13 through 22.